Okay, this is TempleOS 5-minute random code walkthrough, episode number 11, and I'm your host, Terry Davis. So let's see where God takes us today. Alt-B, and we are in, we're back in the back end of the compiler. This is where common library routines are stored. And this is IC-move. This is one of the most common intermediate code library routines. Every time one of the other library code, one of the other just to show you, I'm going to find all instances of IC-move. There are hundreds of them. In the other intermediate codes, it uses this IC-move. Okay, so this is a building block to make other intermediate codes. So what does it do? There's two arguments are specified by three values in the compiler, and I forgot whether it goes left or right. I think you go here. So the first argument is type 1, register 1, displacement 1. The second argument is type 2, register 2, displacement 2. And IP is the instruction pointer for in the last pass on the back end, you generate machine code, and the IP is a pointer to the current position in the buffer for your output machine code. So anyway, so the type, there are about 5 types. Let's see, there are 7 types. An immediate value, a register with displacement, a displacement, SIB, that's a indexed, that's a register with an index register, then RIP relative, and or the stack. Anyway, so the move has to handle all those cases. It turns out these three cases are very similar, and anyway, so let's see what we have here. So one case is a move to a register. I think this is the destination number. I think it goes. Let's find out. I'm looking to see whether it goes from left to right or right to left. It goes from right to left. Let's see. I just want to check one more time. Yeah, okay. It goes from right to left. Okay. So this is the destination. If the destination is a register, we can zero the register, or we can load it with the immediate value. Let's see where it handles the immediate value. Okay, if it's an immediate value, this is loading an immediate value into a register. All this. The reason there's all those complicated cases is because if you're loading a byte value, you use one opcode. If you're loading signed or unsigned, if it's a signed value that's negative, you can use that. If it's a 32-bit value, you use that. If it's a 32-bit signed value, you use that. Otherwise, if it's a 64-bit value, you use this. So the first part is for moving an immediate T1, T2, D2 into register T1, R1, D1. So the second case is the stack. This is the okay, it's calling another library routine called push, which pushes a value on the stack. For displacement, RIP relative, or for indexed, it's going to use a modder 2 modder. It's going to use a modder. This is a for a lot of the opcodes, you have something like RM64, and what that is a move from let's see how to explain this. It's a register or memory into a register. So the RM values are register or memory into a register. It can also you can also have an immediate. This is a common addressing mode in the x86 architecture, and all these cases can use this mode. So here's where it's putting the displacement in the instruction. When you have an offset off a register, you have a displacement. Here's where it's deciding the rex, which is the 48 for rex is the prefix for 64-bit instructions. It includes what they did is they took the increment and decrement instructions from the 386, and they confiscated those opcodes. So now it used to be that 40 through 44F were increment and decrement a register. Now they've been taken over, and 48 means use a 64-bit size. The 1 bit is that tells it that to use the registers are 8 through 15. So if you have a 48 plus 1, that's 64-bit size, and then there are 3 bits for extended registers. The modder is move register into a register. So there's a register, and then there's the register or memory. So like with the move opcode, you move to R1, comma, let's say 12 off of R2, something like that. So there's a register on the left. There's a register on the right. This one can also be reversed, right and left. And then sometimes you have a register 3 in this position. So you can have this many registers. So there are 3 bits for extending to the upper registers. So that's what the rex is all about. And RIP relative is an option. No, not, yeah, it is. Okay. It turns out that in 32-bit, you have if you say move EAX, comma, and then you say a value, that's a constant value. But in 64-bit, it turns out it's RIP plus a value. So they changed how that addressing mode works. Anyway, so this is what I'm talking about. This set IF code final. If you're using RIP relative, then you have to tell it to recalculate. This is past 7, 8, and 9, so it's not final because code can shift around, and if code can shift around, then the RIP offset can shift around. So this tells it to redo this intermediate code instruction because it's not final. Other opcodes can be finalized and then you can ignore them. But if it has RIP relative, then it's not final. Anyway, so how about that?